Hey everybody, this is Mr. Chernitzky. This is Module 3, Lesson 1. Not a whole lot of math in this, but more just some definitions. Um, what we're talking about today is the idea of how do we gather sample data. Now, we've already talked about what the difference between a sample and a population. A sample is essentially, if this is my population, a sample is just some representative chunk of that sample. And our goal with a sample is we want the best representation of the entire population. We will never ever get a perfect representation. In other words, there will always be some error called a sampling error or sample error. You'll always end up with some sort of sample error just because you're not really reaching everybody in the population. However, in most cases, if you've got a very large population, it is virtually impossible to get the entire population. You can only get a sample, and so the idea is to avoid or reduce as much error as possible. Now, there's three ways that we can gather sample data. One is through an observational study. Um, that's where we either sit back and observe what's going on, or we do a survey, but we're not doing any sort of manipulation or setting up variables and things like that. We're really just observing and recording. We're not doing any sort of setting up any variables or anything like that. The next um, type of gathering data would be to actually set up an experiment where you take a group of subjects and you set up the variables, and just like any other experiment, you have a control group, and everything is controlled, and you run your experiment and you write down your data. And the last would be a simulation, and this is the case where we ask the computer to run an experiment for us, and our subjects are not actual people or subjects or living things, but they are computerized objects. So, for example, let's say that we are interested in gathering data about the how people are going to the concessions at Mile High Stadium. I guess you're calling it Empower Field now. So, a couple ways we could how would we go about doing this? So, um, the least intrusive way um, is to do an observational study or to do a survey, and you could survey people in the stadium and gather data that way. An experiment would be kind of hard for a couple of reasons. So, one thing about large scale experiments is that they're very expensive, and you have to take into considering ethical considerations. Go away. Why is that not going away? So, for example, I can't, in good conscience, go to the stadium and tell everybody in one section that they have to eat a certain type of concession, or they're not allowed another type of concession, just to kind of play around and see, well, how does this change things? There's When you're dealing with humans in your experiments, you really have to be considerate of ethical considerations, and you have to consider the cost of doing things. It's not really feasible for me to get, I'm not sure exactly how many people fit in Malice, but whatever, 70,000 volunteers and then run experiments. That's just going to be extremely expensive to do. The other thing that we can consider is a simulation, which is kind of like, if you ever played The Sims, that's kind of like a simulation. You have the computer create sort of human representations, and you can put in different scenarios and have them act out accordingly. So simulations can be very good, but it's very broad in terms of behavior. In other words, generally human behavior is easy to predict in a very broad sense, but kind of difficult in a specific sense. So in other words, I can generally kind of predict, which people are going to be moving to which concessions just on simulations, but you're also not going to have in the simulation more likely the oddball person who, I don't know, gets a phone call and is walking around the stadium 3 times talking on the phone, and then eventually winds up at some other concession. It doesn't take into this council's very odd specific behaviors. It's just hard to program that kind of a very specific behavior. It's good for simulation, like for example, when they want to figure out like traffic patterns leaving a stadium. You kind of programmed, okay, we've got this many people probably leaving wanting to go this way, this many people probably leaving going this way, and we can filter out who's going to try and leave early and who's going to maybe take their time, and you can run the program and vary those type of things and kind of get a good idea of how people are going to exit the stadium, and that's how you can hopefully predict traffic patterns, although in my opinion they don't do a great job. In my opinion, so there's always tons of traffic on game day. All right, we'll talk about problems with surveying in a moment. So the whole idea is inferential statistics. We want to be able to make inferences. We want to be able to make good conclusions or predictions, I should say, based on the data that we gather. In order to do that, we have to be very clearly define the population. If we're dealing with the stadium, that is going to be Denver, or just in general, football fans in the game. Actually, that's another thing you have to consider. It may not just be Denver people in the stadium. It could be people from out of town and other things like that. Clearly define what you're trying to measure. So in this case, we might be measuring concessions. What type of concessions are being bought and enjoyed. Clearly define how the sample managers were selected. This is important. You need to disclose that kind of data, because if there's error, which we'll talk about how there could be error, and you don't disclose that, then you're kind of your conclusions could be called into doubt, because we don't know exactly how you selected people. You could have actually been kind of nefarious in terms of how you selected people in order to get the results that you wanted. And this is a very bad problem in statistical data gathering from bad parties who just are working to get the answers that they want. You can manipulate how you ask data and who you ask, who you gather data from, and that happens all the time. So that's why you want to know when you're looking at results of a survey, how did you gather your data? How did you select your the members who you sampled from? As we mentioned, we want to use samples that represent the entire population, and we want to avoid bias. So there's lots of ways that we can get bias. Okay, so errors in sampling. So bias design. Bias design happens when we have essentially bad or leading. Let's switch to a different color here. We have like leading questions or unbalanced questions. So leading questions would be like you're asking everybody in the Denver Stadium, uh, you know, don't you feel happy that or don't you feel lucky that you are um, able to choose from such a wonderfully wide variety of excellent um, concessions? That's leading a person to an answer that is positive, versus if you were very a non-biased would be just a simple rating of how you feel the concessions are in Mile High Stadium. Unbalanced would be like if you had more responses that were positive, and for example, if you had maybe a question that was, oh, how do you feel about the concessions? And your possible answers were excellent, super excellent, the best I've ever had, and then you had maybe two left with a okay, and then I don't like it was the last one. So you've got three possible answers that are positive, and only one that's neutral and one that is negative. So you're going to bias by design. You're going to get more people saying that they like the concessions. You're not going to get an accurate. And as I said before, there are bad characters who do this on purpose to get a biased answer when they do sampling. Convenience sample error. So let's say we're going to test again. We're doing our looking at our concessions question. But you know what? We got tickets to the game too, so we want to watch the game, and so what we're gonna do is we're gonna stand out front, and we are just going to ask the first 50 people or the first 100 people that come into the stadium. Just because it's like, hey, let's get done, and we'll be done with it, and we can watch the game. Um, that's what we'd call convenience sample error. So the problem with that is, obviously, your sample population consists only of people who get to the stadium early and go right to the game. You are missing everybody who goes to tailgate, everybody who's running late to the game. Your sample is not a true representation of the entire population. So because you were trying to be convenient, you're developing an error. So you have to be very careful of convenience error. Basically, that means that convenience is usually you're going to the people that are closest to you for your convenience. Voluntary response. This is also very bad. So, voluntary response. There's major problems with voluntary response. This would be like, hey, you have a link, after the game. If you want to, you can comment on how you felt the concessions were at the stadium. Very easy to set up. Very easy to gather data, but there's a huge problem with that. With voluntary response, you either get it's very bimodal. You'll either get very positive or often very negative. Because most people who get a medium or feel kind of medium aren't going to take the time to write a voluntary response. You see this in Yelp reviews or Amazon reviews. Those kind of responses, it's either very positive or very negative. You're not getting a very good cross section of the population. Okay, under coverage. Let's say I'm doing my I'm testing something in Mile High Stadium, and I'm saying I've got a lot of population here, and they're coming from all sorts of places in Denver, and they're all sorts of different demographics. So maybe this is a really good way to gather data. Here's the problem. If I'm asking something like doing like a political poll at the stadium, what's my undercoverage going to be? Well, I'm only testing people who are generally sports fans, and in fact, only people who are generally interested in football. So I'm going to miss anybody who's not a sports fan. I'm going to miss people who are not really football fans. I'm also going to miss people who generally, even if it is like I'm interested in football fans and all that, I'm going to miss people who can't afford to go to the game because um, even the cheapest seats in Mile High Stadium are very expensive. It's a very expensive day to go to a football game, and so my poorest people are going to be undercoveraged. And this happens a lot in um, data gathering. If you do um, internet polls or anything like that, where you have to take into consideration people don't always have good internet access. If you're going gathering information, going house to house, there are people who are living in temporary housing or are homeless. You're not getting coverage from them, so you have to be very careful about how you're gathering data. And if you are not careful, you're going to miss um, gathering data from probably the people who need representation the most. So undercoverage is a major problem. Non-response. So non-response is a bias where we're not getting information from people who don't want to um, take the sample, and you can't force people ethically to take a sample. You can't force people at gunpoint to take your, to do your survey. So a lot of times you're gonna have, like, if I waited outside the gates as people were leaving and tried to sample them, well, I'm only going to get response from the people who are going to take the time after a game to fill out a survey. Um, Everybody who's rushing to get out and just like doesn't want to deal with it, I'm not going to get any information from them. So I'm going to get non-response bias. So these people who are not responding have good data that I want, but because they are not responding, I'm missing that. I'm only getting the people who are taking the time to respond to this. And you get a lot of this, for example, if you are doing calls to people during the day, to households during the day, um, the only people who are going to have take the time to do this are going to be people who have time during the day to fill out, to answer questions on a phone survey. So that's you'll get a non-response bias. So that's just people not willing to answer. Let's go ahead and fill this, make sure we get everything covered here. Convenient sample was sampling only the people closest or most convenient. Undercoverage was missing representation of certain groups. Based on how data was collected. All right, response bias. A response bias is people not answering truthfully. And there's lots of reasons why people would not respond truthfully. If I'm at the Mile High Stadium during a Denver Broncos game and I ask everybody there who they think is going to win the Super Bowl, most people there are going to say uh, Denver Broncos, and most likely that's could be a social pressure. Everybody's wearing their Broncos gear. Everybody's pumped up about the team. Doesn't matter that they might be, 3-8 and then no chance to make the playoffs. Um, People are going to bias their response if they feel that they're going to be judged by that response. Um, One way we can try to get is to try to avoid that is to allow for as much anonymity as possible instead of asking them, verbally. You have them fill out um, using pen and paper. You don't collect their name or anything like that or any other data that could be connected to them. However, even with all that method, sometimes response bias is just unavoidable. Some people don't want to confess to certain information if they feel like they might feel have some social pressure. They might be judged by that. So that's response bias. Some other ways we can avoid some of these non-response. Sometimes giving people a motive to fill out a survey. If you, for example, hey, if you fill out this survey, we'll give you a free free hot dog or a Broncos shirt or something like that. You might get more people to respond, but that also increases your costs. Um, Voluntary, you know, or sorry, it's very hard to get voluntary response to be um, accurate. So I would avoid voluntary response pretty much in general. Convenience is, is just simply being better design in how you gather your data, which we'll talk about in the next one. Bias design, we've talked about that. Really read through your questions, make sure they're balanced, make sure you're not leading people to the design that you want, to the answer that you're hoping to get. All right, types of sampling. There's two types. There's representative sampling and there's random sampling. Okay, so random sampling is exactly what it sounds like. It is completely random. It's spread out, totally random. Um, Representative sampling is more of a strategic. You're trying to get a true cross section of your population. So you want to make sure, with you doing representative sampling, you're making sure that all the groups that you are interested in are represented proportionally. So we'll start out with some random sampling. Simple random sampling, that's also known as abbreviation as SRS. This really is, the analog way of doing this or thinking about it is names out of a hat, or actually, we wouldn't even do names, it would be numbers out of a hat. I'm going to put parentheses on hat because really I don't do that. Numbers out of a hat. So you take your entire population, you assign everybody in that population a number, and we pull however many we want to sample, 50, 100. Okay. Bear in mind that as we talked about error, error we can reduce the number of error, which is our goal. If we were to graph error versus number of samples, or the number of your sample, look something like this. We never gets to zero. As we said, we never get to zero. In fact, actually, the only time you get to zero is if you sample enough so that it is the exact same. Your sample is your entire population. So that's your sample error. So if you take a very small number, you get high sample error, and as you get more and more, but you get to a point where just increasing the number, you're not going to get as much bang for your buck. In other words, if I have this many, I'm like, okay, this is my sample error, and then I double that, I'm only going to reduce my sample error by a little bit as I get further and further along here. So while at the same time, I could be doubling the cost of my collecting data, which is also not good. Okay, you're only going to have a certain budget to collect data. It'd be nice if we could, otherwise, if we could test everybody. But that's the whole point of doing a sample, is that we don't have the capability of doing that. We can't test, and collect and analyze huge samples. So we have to kind of find that nice balance. Okay, so simple random sampling. In the case of our stadiums, an SRS would be every single ticket is randomly put into a hat and assigned a number. And instead of a hat, what we usually do is we do a random number generator. And you can Google a random number generator. It's a pretty standard thing that even your graphing calculator can do. But that will randomly select 50, or whatever, no, we'll just say 50 people from throughout the stadium, and that is our sample. That's a simple random sample. Stratified random sampling. Okay, here's the problem with a simple random sample. I've got my stadium here, and simple random sample. Just by pure chance, maybe, because it's purely random, maybe I gather an unbalanced, pure by chance, an unbalanced number of people who are in the lower sections, and an unbalanced number of, a smaller number of people who are sitting in the upper sections. So maybe this is the upper, that's the lower sections, and that's just pure chance it happens because it's random. And so my data is going to have a fairly good error. Like I said, one way we could get out of that is by just taking more number. The more number we have, the less chance we're going to have an unbalanced sampling, but we may only have the budget to sample 50 people or 100 people or whatever that is. So maybe we want to make sure that everybody, we get an equal broad representation from every section. Okay? So maybe that's what we do. Instead of a going everybody in the same hat, what we do is we go up here and we test randomly one person from each and every section. Now we've got somebody in each section, and each sections are what we're going to call strata. Okay, that's how we divide everything up. So it's whatever group we're interested in. So we could have done it also, we could have broken it into, male and female, or into age groups could be my strata. If we want to, as we said, we're not purely random sampling. We're now trying to get into more representative sampling. We're dividing it into a proper, to get better representation, just because we're limited in the number of people that we can sample, so we want to make sure that we get a good cross-section. So each of those sections would be a strata, and that would be a stratified random sampling. A systematic sampling, by the way, I realize that systematic random sampling also has the abbreviation SRS, but when we say SRS, we always mean simple random sampling. Systematic sampling. This really is just the same as a simple random sampling. It's just that instead of using a random number generator for every number that we have, a systematic sampling would be, hey, we'll do a random number pick for the first, 1 through 100 tickets. Okay? So that gives us whatever. For example, we randomly picked number 53. Okay. From there, I'm going to get my remaining volunteers or people I'm going to survey by adding 100 to each one of those. So I'd get 153, 253, and so forth until I had the number that example of people that I want. So it's still fairly random. It's just that you have to be careful. Just make sure that something like this. You could run into an error if your ticket numbers were in such a way that by doing this, like let's say, okay, I get through the whole stadium, but all by doing this plus 100, I'm only getting the people in the bottom section of each section. So as long as that's not going to occur, this is still an okay way to pick your numbers. It's a very quick way to do it. And that's why we would do systematic sampling, is that you don't have to carry a excuse me, you don't have to do a random number generator, and you'd have to have, if you had a very large number to gather, and you'd have to very tricky to find all these random numbers. So at least this one kind of spreads it out evenly, so it's easier to find these people. Cluster sampling. Well, let's just, again, we're always trying to reduce cost without too much undue error in gathering our data. Let's say I don't want, I want to do something like a stratified random sampling where I'm gathering data, but I don't have the resources to go to every single section and randomly find one person from each section. That's not going to work. Don't have the resources for that. It's only me and a couple, volunteers, and it's just not feasible to do that. One thing that we could do is a cluster sampling. So cluster sampling would be, here's our stadium. I'm going to gather a number of volunteers from the upper. I'm going to gather another group of random volunteers from the middle, and I'm going to grab another group of volunteers from one lower section. Okay. So if I was at the stadium, maybe instead of going around and each one from each section, I'm going to do a cluster. I'm going to do a group from that section, a group from that section, and a group from that section. And that way, I've got my good cross section. I've got upper, middle, and lower all connected. And I can get probably pretty good, good representation. So we're generally okay with cluster sampling if we believe we have reason to believe that each cluster is a representation or contains, I should say, good representation of our population. Okay. In other words, we're not worried that that if we did that, we would be missing any sort of demographics, or that in this one particular section there's only men sitting in that one section. So as long as we're pretty good that things are spread out within those three, we can do a cluster and feel fairly confident about getting a good cross section. There is, like I said, there's always going to be a little bit of error by doing something like that. You may, for example, be getting an error in terms of, well, these are people who are more, aligned with kind of the end zone. They might be a different demographic than people who want to line up at the 50-yard line or something like that, or in the end zone or behind the goalpost. That might be a different type of crowd. But depending on what you're asking for, this still might be a perfectly okay cluster. And that's it. That's our definitions or vocabulary for sampling. So next thing we'll talk about is experiments, and we'll get into more about how we do proper experiments and gather data that way.